Hello everyone, this is the presentation of Team Java Strong Remove Python. In this presentation, we will introduce three different agents used in our silo. So why we use bland search? Because the problem can be analogized to a tree model such as BFS and DFS. If selecting bland search, no need to require extra information, no need to consider how to build a heuristic function. BFS is very suitable because the cost of each step is the same. Therefore, it could be optimal theoretically, but BFS has its own problem, like expansion will be huge. Even more, BFS focuses on local rather than systematic. This page shows the process of BFS, pushing the positions and generating every possible solutions, calculating the score, only selecting the max one. Because BFS cannot simulate the selection of the opponent, therefore, we could only generate our own local optimal solution based on the opponent's optimal solution. The improvement of BFS focuses on using the strategy of the game rather than considering the game systematically, because BFS is born with greedy, corners, edges, and center are strategic positions, which will lead to victory. Some trap position shouldn't be captured because it will give the opponent chance to capture the corners. As we can see, the improvement does do something. The next, Yigal will introduce her idea.
Thank you. So the general idea of MCTS is to choose an optimal action given a game state. The node stores next page. So the node store the statistical information of this node, which are reward and visit. These values form the UCT function. The reward function is that the winner gets a reward equal to the difference is plus 10. Next page. So the player of both sides randomly choose the legal actions for each move during the simulation process, which cannot guarantee stable results after the simulation. Therefore, the improvement is to prioritize algorithms and select the effective action with the highest priority for each move during simulation. Next page, please. So after testing the model, the winning rate of the basic model against the random agent is maintained at 99%. After the model is optimized, the winning rate of the optimized model against the basic model is about 75%. The main advantage of MCTS is that the model is easy to implement and the winning rate is high. But the main disadvantage is that the result obtained within a limited time may not be the optimal solution. Next, Yilin will introduce the reinforcement learning.
Thank you. So part 3 is the third algorithm, reinforcement learning. Next page. First, motivation. So why RL? RL methods are natural ways for exploring game strategies, and it doesn't need accurate labels at the beginning. In our case, we need to choose behaviors based on value, and the method must be model-free. However, traditional Q-learning doesn't work effectively when the dimension is high. Besides, experience replay and fixed Q target can provide stability and reduce correlation. Next page. As for the application, one of the core ideas of DQN is to utilize a Q table to store the Q value of all state action pairs and update according to the difference between reality and estimation. Next page. The experience replay. Data will be recorded and stored in the replay memory or buffer. During Q-learning stage, the algorithm will perform sampling in the buffer. Next page. The neural network. The left picture is the general structure of the two networks. They have same structure, but evaluation net is always being promoted while the target network's parameters is frozen for a period of time. The picture in top right shows the mean squared error loss function, and the code displays how I build the two networks. Next page, the environment. The main functions are step and reset. Step function aims to output proper one-round rewards and endgame rewards according to the agent's actions. Reset function is aimed to initiate the whole game. So that's all for our presentation, and thank you for listening.